Hi, I'm Gus from Centre for Net Zero. We've got Sheng here as well, also for Centre Net Zero. We're going to do a little presentation, which is a preview to a workshop we're running this afternoon at 1:30, and it's basically how to train a generative AI model to create synthetic smart meter data, and it's all wrapped up in the project we've launched this year related to this called OpenSynth. So I'm going to do a few slides, just a quick intro to us, the model we created and the community OpenSynth. Then I'm going to talk about the workshop we're running this afternoon. Cool. So Centre for Net Zero, we're a research institute founded by Octopus Energy Group, which is one of the biggest energy retail companies in the UK. We're kind of autonomous, so we don't do commercially based research. And we mainly focus on designing and running research and field trials with Octopus Energy's customer base, but also doing modelling projects to model the future energy system, which is mine and Sheng's team. Our goal is to accelerate the journey to a fully sustainable global energy system. Probably the same goal as most of you guys. So what have we done? So we decided a few years ago, well, Sheng kind of kicked it off. Octopus Energy were getting loads of requests for smart meter data for research projects. So we started to look into how we could generate synthetic smart meter data, really high quality smart meter profiles that are generated from machine learning algorithms. So we basically can release them publicly. One of the main problems with smart meter data in the UK at least, and most places, is that it's private, so you can't just hand it out for research projects. So Sheng here created a really high quality model to produce synthetic data. It's based on smart meter readings of Octopus Energy's customers, and critically it can be conditioned on different attributes, different low carbon technology mixtures, seasonality throughout the year, and household energy ratings, so that we can create smart meter profiles for different types of households in the UK. And what that allows us to do is then model future scenarios. So imagining increasing the uptake of electric vehicles in a region to 100% and see how the demand in that area changes. I think I've got these slides mixed up because that was what I was meant to talk about first. But yeah, so yeah, we think smart meter data is really key for a successful energy transition, understanding demand at a household level. And most of the data we've got, especially in the UK, is based on either old collected data from a few years ago or highly aggregated data at the kind of medium and high voltage level, not at the low voltage household data. And the data itself is highly restricted because of privacy protection. Then go into the model we created that I just talked about. So we created that model, and then we were like, what next? And we realized that we really needed to accelerate the amount of synthetic smart meter data in circulation for people to use for research purposes. So we got in touch with LF Energy and started to think about building a community. And we had three goals. So we wanted an area where people could easily generate their own synthetic smart meter data if they were holders of smart meter data. We wanted to encourage people to create the data and share it. So different regions have different characteristics, different weather patterns, different types of households, different low carbon technologies. So we want synthetic data from as many different regions as possible. And we want to kind of spread the adoption of this synthetic data, so lots of researchers and commercial organizations around the globe can use it for their own purposes. And what have we done so far? So this year, early 2024, we launched the community. It was kind of a soft launch because we didn't actually have any code or data publicly available at the time. But we had a really great event at Octopus Energy HQ, and where we talked about what we wanted to do and our plans, and had a really good turnout. In July, we released an academic paper called Defining Good, which was meant to be a start of a 10 for an evaluation framework for synthetic smart meter data. So we think for people to really trust this data, we need to put quite a lot of work into making sure that it's not only actually private, but it can be used in place of real smart meter data, and we need to define the metrics that actually quantify this. So this paper kind of focused on three main topics: fidelity, how kind of realistic the data is; utility, how well the data can be used in place of actual smart meter data; and privacy, how private it is, how easy it is to kind of get through to the raw personal smart meter data. And the main kind of takeaway from this is that those three kind of aspects are all intertwined, and you have to balance them for your particular use case. So we released that, and then in the same month we released the kind of first version of the OpenSynth code repository. So we've got our algorithm on there, Faraday, and so that can be used to generate your own synthetic smart meter data for if you're a holder of raw data. And the idea is we want not only more people to kind of contribute their own algorithms or kind of versions of the algorithms to the repository, but we want to add kind of the metrics that we've started to define in the evaluation framework to the repository, so that people can benchmark those algorithms on kind of standardized data sets and see which algorithms are best for their use case. And then the final bit of the puzzle is the OpenSynth data repository. So we, when I wrote this, we were planning to release the data on Zenodo, a first public synthetic smart meter data set from Faraday, and we hadn't done it then, but I literally got the green light to release it about 10 minutes ago from Octopus Energy's legal team. So we're going to probably do that today. So there'll be a public synthetic smart meter data set on Zenodo for free download and use in your research projects. So on to the workshop. So this workshop is hands-on. So there's the kind of ability to run some of the code and generate data and do some of the things yourselves. But we'll also be kind of talking through some of the topics as well. It's also going to follow the evaluation framework paper, kind of the same topics. So the first kind of section is going to be around training the model. And then we're going to look into privacy, and especially differential privacy, which plays a huge part in the analysis we did. And then we're going to kind of touch on the fidelity and utility aspects at the end. It's in Studio 4 at 1:30 if you need reminding. Training the model, we're going to introduce you to generative models in general and how Faraday works. And then we'll have a notebook where you can train the model with and without differential privacy. Then privacy, we were going to talk about the two main methods we used to determine how private the data is, and that is reconstruction and membership inference attacks, and the specific things we did related to smart meter data, which kind of is different to normal methods. And then we're going to, again, run through an exercise to attack these models. And then fidelity and utility, we'll run through the methods we use to measure fidelity, but there's normal statistical kind of methods, but there's also metrics we came up with specific to smart meter data, which is quite interesting. And utility, a couple of methods we use to kind of try and benchmark how useful this smart meter data is, and then potentially get on to training a classification model, which is how we do utility on this data. So that's what we're planning to do. It'd be great to see some of you there. We'll probably have it on a screen as well, so if you don't want to run through the actual code bits, you can see how we do it and listen to some of the discussions. But yeah, that's all I had to run through. Does anyone have any questions on this, the workshop, or synthetic data, or OpenSynth, or anything? Anything anyone wants to know?
Sorry if I missed this. Are you focusing only on residential AMI at this point, or are you addressing other commercial loads?
Yeah, great question. At the moment, we've only got residential synthetic smart meter data, mainly because our partner organisation is mainly a residential energy supplier, but we absolutely need to do this for commercial organisations as well. The difficulty is it's much harder to get the raw data for commercial organisations. There's usually private kind of deals, and the data isn't as centralised as domestic, especially in the UK. And also there's just a lot more variability. It's easier to group domestic buildings together, but yeah, all sorts of different types of commercial buildings and power usage profiles and that kind of thing. The other thing is, in the UK at least, a lot of at least the big commercial and heavy industry goes in at the medium voltage level. So we're kind of like, if we are just focusing at low voltage, it's less of a need for the research that we're doing. But yeah, if anyone's got any CNI data out there, please let us know and give it to us, and we'll do something with it. Yep.
Kind of a related question. So, as you step away from residential and start to deal with commercial, have you given any thought as to whether the methodologies you're using would even work for industrial?
Yeah, another good question. Because the algorithms we've trained are on standardized 30-minute smart meter profiles, and there's all sorts of different energy demand profiles out there, and even different countries don't follow the same patterns. But that's one of the reasons for OpenSynth. We think there'll be different algorithms needed for different use cases. We can't imagine we can just copy and paste Faraday not only on different between domestic and CNI, but to different countries. So the more algorithms we have there that are specific different use cases, the better we'll be able to cover all of the different types of profile.
I guess how do you account for the energy crisis scenario that has been going on in the UK recently? For example, with the change of the price cap going super up and then recently going down again. I don't know what is the time frame of the dataset you use for training, but how is that? How can that be reflected or removed or accounted for future generations?
Yeah, another really good question. So the current version of Faraday is, I think, just 1 year, 2022. Is that right? 21, 22. And then the next version we're doing is going to be last year, essentially. So not only is it hard to capture extreme price events, but there's also extreme weather events we need to think about. And the answer is, we're not doing that at the moment. But so we need to figure out how to train these models on longer time periods where we're seeing more of these extreme values. But also another idea we have is, so if we kind of globalize this, then maybe another country's weather patterns now it will be similar to another country's in the future. So, for example, if the UK in 20 years that has got slightly hotter, then maybe we can look at another country which is. Do you see what I'm saying? And try and make those kind of comparisons. So which all kind of points to getting as much of this data around the world as we can, so that we can do those kind of modeling exercises. Whoa. Let's go Santiago.
What would be some example of something that you do with this data?
Pardon?
What would be an example of something that you do with Faraday?
Yeah. So one thing we have started earlier this year, and we want to try and kind of expand on it, is a kind of grid visualization tool. So we did it for a very small region in London, where we have profiles for all of the households in that region, and then we can kind of simulate different scenarios and see how the demand changes. So yeah, we think it can be used for grid planning, but also kind of more long-term kind of analysis, maybe to try and find tipping points and to try and break like the current infrastructure under certain scenarios, and yeah. Gentleman behind.
Yeah, well, I was curious to use cases, so you will answer that one.
Yeah.
Have you been able to verify the results using synthetic data comparison to?
Yeah. So just quickly going back to the use cases, so we have an alpha kind of web app and API for Faraday, and quite a few organisations, mainly in the UK, are using the data for their own research. One of the early things that happened is the University of Birmingham kind of tried to, were using the data and they were validating it against smart meter data they had for regions in Birmingham in the UK. And in general, it's like really, really good kind of shape fit. They noticed a slight bias issue between their data and ours. So so our data was slightly higher consumption than theirs. So we kind of did an exercise earlier this year to try and remove the bias in our data and make it nationally representative by a kind of a sampling strategy out of Octopus Energy's customers. So we've actually done that, and that will be feeding into the next version of Faraday. So we think the data will be kind of more UK nationally representative. So yeah, that's one way we're doing it. But then also with the fidelity and utility metrics we lay out on the paper, provide a good kind of framework for how accurate it is, I think. Is it 15:15?
Yeah, it's yeah.
Okay.
5 minutes past 4.
Catch me in a minute. But thank you very much for coming. Hope to see you at 1:30.